Good afternoon, everyone. My name is Sachin Prakash, and I am a senior faculty of chemistry at Narayana IT Academy. Today, we are going to discuss the 22nd January Shift to 2 paper for JEE means 2025. Okay, so let us begin our paper. So, question number 51. Density of 3 molar NaCl solution is given as 1.25 gram per ml. What will the molality of the solution? So 3 molar NaCl we can write as 3 moles of NaCl in 1000 grams of solution, 1000 ml of solution, and density is given to be 1.25 gram per ml. So it will be 1250 grams of solution. This is my weight of solution, and NaCl molar mass is 58.5 grams. So if you multiply it, you'll get 3 175.5 grams of NaCl. Now, what is the weight of the water? Weight of water would be 1250 minus 175.5. That would be 1074.5. Okay, so molality will be moles of NaCl by weight of water in kilograms. So it will be moles of NaCl, which is 3, by weight of water, which is 1.0745 kilograms. Now when you do this, now 3 by 1 will be 3, so 3 by 1.074 will be slightly less than 3. So it should be coming out to be close to 2.79. So the answer should be option 4. Okay, so this is question number 51. Next is question number 52. Says which of the following alkanes will have 2 secondary hydrogens? Okay, so the correct answer should be option 3, which is 2233 tetramethyl pentane. Let us draw the structure. So this is pentane, and this is 2. Okay, so this is 2233 tetramethyl pentane. Now if you see, this is a 2-degree hydrogen, 2-degree carbon, and the hydrogen which are connected to this are 2-degree hydrogens. So there are two 2-degree hydrogens in case of 2233 tetramethyl pentane. So this will be the correct answer. Next is question number 53. The molar solubility of zirconium phosphate is given by. Now zirconium phosphate is Zr3 PO4 whole 4, and this will dissociate in pure water to give 3Zr4 plus 4 PO4 3 minus. If its solubility is S, then this will give 3S and 4S. So Ksp should be equal to concentration of Zr4 plus to the power 3 into concentration of PO4 3 to the power 4. So this will be equal to 3s to the power 3 into 4s to the power 4. So you'll get s to the power 7, and this will be equal to 3 to the power 3 into 4 to the power 4. So 3 to the power 3 will be 27, and 4 to the power 4 will be 16 square, which is 256. So if you multiply it, the last term should be coming out to be 2. So 27 into 250, 400. It should come close to 6912. Okay, so the answer should be So if I am talking S, it will be KSP by 6912 to the power 1 by 7. So correct answer should be option 4. Next is question number 54. Okay, given below are two statements. Okay, statement 1 is that nitrogen, sulfur, halogen, phosphorus are present in organic compounds are detected by Lassen's test. This is a correct statement. While statement 2, elements present in the compound are converted from covalent form to ionic form by fusing it with magnesium. Now, Lassen's test is heating with sodium, or is this called a sodium fusion test. So obviously magnesium is the wrong okay element. So statement 2 will be incorrect. So our statement 1 is correct. Our statement 2 is false. So the answer should be option 2. Next, we have got question number 55. Statement 1. Corrosion is an electrochemical phenomenon in which pure metal acts as anode while impure metal acts as cathode. Now let us explore this statement. Okay. So we have got iron which will be getting oxidized to Fe3 plus. So here the pure iron will be acting as anode, whereas at anode oxidation takes place. So first half that pure metal acts as anode is correct. Now what is happening that the oxygen which is present in atmosphere in presence of H plus and electrons will be giving OH minus, and this OH minus with Fe3 plus will be giving FeOH whole thrice, which will be deposited on impure metal. Okay, so we can say that the impure metal will be acting as cathode. So statement 1 is correct. Okay, now when we talk about statement 2, rate of corrosion is more in alkaline medium than in acidic medium. This is a wrong statement because if H plus is there, then the rate of reaction will be more. Okay, and hence the rate of corrosion will be more. So if we so in alkaline medium H plus will be less, so rate of corrosion will be less. So the statement 2 is incorrect. So statement 1 is correct while statement 2 is incorrect. So the correct option should be option 3. Next is question number 56. Identify the number of structures which can be correlated to D-glyceraldehyde. Now for this assigning capital D or L configuration, we have to take highest numbered chiral center. Okay, with numbering starting from the highest oxidized carbon. So which is CHO in all these cases. So the numbering in this case is 1, 2, 3, 4. It's the C3 which is the highest numbered chiral center. Okay, here OH is on the right. So it is a capital D configuration. In second case, 1, 2, 3, 4, 5. Here C4 is the highest numbered chiral center. And here OH is on the right. So again it is a D configuration. Okay, next here again numbering is 1, 2, 3, 4 and 5. Again this is the highest numbered chiral center. Okay, now here OH is on the left. So it is coming from L glyceraldehyde. So this is an L configuration. And in this case the numbering should start like this: 1, 2, 3, 4, 5. Okay, now you see here the molecule is like has to be rotated, so the CHO is on the top. So if we do that, then the molecule will look something like this. You have our CHO. Now the OH will be on the right, the third OH will be on the left, fourth OH will be on the right, and fifth OH is attached to a chiral center. It won't matter that much. So 1, 2, 3, 4, 5. Again here the OH is on the right side, so it's a capital D configuration. So this is also capital D. Okay, so A, B, and D are can be derived from D-glyceraldehyde. There are three compounds, so the correct answer should be option 2. Okay, next is question number 57. Maximum covalency of non-metallic group 15 element E with weakest EE bond. Now in group 15, the elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. Where bismuth is metal, these are metalloids, and these two are non-metals. So we have to actually compare the bond energy of NN and PP bonds. Now PP bond energy will be greater than NN bond energy, because in case of nitrogen, due to the repulsions between the 2p lone pair, okay, the repulsions will be more, bond energy will decrease compared to PP. So weaker for between the non-metals, the weaker bond in the least bond energy will be having before nitrogen, and nitrogen will having maximum covalency of 4, which you can observe in case of NH4 plus also. So the correct answer should be option 3. Okay, next is question number 58. Okay, so in 58 you have got RBr, okay, which is reacting with magnesium. Now when RBr reacts with magnesium, you get R minus plus MgBr plus. Okay, and this R minus, on taking acidic hydrogen from water, okay, you get RH plus OH minus. So basically bromine is finally substituted by hydrogen, and this is corresponding to 2-methyl butane. So which alkyl halides will give, and they are only asking for structural isomers. So let us see what are the possibilities. So one is this one. If you put bromine by hydrogen, you will get a 2-methyl butane. Another is this one. One is this one. Now here they are only asking structure, so we don't have to worry about chiral center here. And last one is this one. So you will get 4 structural isomers. So correct answer should be option 4. Next is question number 59. Okay, so in question number 59, match the following compounds in list 1 with the appropriate catalyst / reagents in their reduction to corresponding amines. Okay, so in this case, if you see amides, okay, now amides on reaction with LiLH4 will give amines RCH2NH2. Nitrobenzene on SNSL, metal acid reduction, will give 5NH2 or aniline. RCN on reaction with H2Ni will give RCH2NH2, and this one is the Gabriel thalamide synthesis, so this will be corresponding to 1. Okay, NaOH will cause hydrolysis, and you'll get RNH2 as the final product. Okay, so in this case the correct option should be option A is 3, B is 4, C is 2, and D is 1. So answer should be option 3. Next is question number 60. Okay, in question number 60 they are asking arrange the following compounds in the increasing order of their dipole moments. Okay, now this is a data based question, but you through a bit of if you check the highest and lowest, you can answer it very easily. Now you see in case of NF3, the lone pair dipole moment will be cancelling out the NF dipole moments. So naturally this will have the so NF3 should have the least dipole moment. While in case of CH-Cl3, the dipole moments will be supporting each other. You see. So the net dipole moment will be getting added up in case of CH-Cl3. Okay. So CH-Cl3 should have maximum dipole moment among. So the only option which where CH-Cl3 is maximum and NF3 is minimum is option 1. So that should be the correct option. Okay, otherwise you have to look into the data. But here through clever manipulation of options you can do this question. Next is question number 61. Okay, so question an energy reaction diagram is given. Okay, where reactant is going to product through activated complex. Now you see, for reactant to product, the activation energy is E1 plus E2. While for backward, this is for forward reaction. While for backward reaction means going like this, the energy of activation is simply E1. Now since product is having higher energy than reactant, product will be less stable than reactant. So activation energy of forward reaction is E1 plus E2 and product is less stable than reactant. So correct answer should be option 4. Okay. Next is question number 62. Reaction between sec-butyl cyclohexane with bromine in presence of sunlight. So let us draw the molecule first. This is secondary butyl cyclohexane and we are reacting with bromine. Now, bromination is a selective reaction. It selectively prefers 3-degree hydrogens. Now, there are two 3-degree hydrogens here. One is this and another is this. Now, both are candidates, but of the more reactive 3-degree hydrogens will be preferred. Now, this side, if you make a radical here, and you make a radical here. Okay, this one is more stable. Why? Because there are 3 plus 2, 5 plus 1, 6 alpha hydrogens. In this case, while in this case there are only 2 alpha, 2 alpha and 1 alpha. 5 alpha hydrogens in this case. Okay, so this will give you us the major product, which will be something like this. So the correct answer should be option 2. Okay, so next is question number 63. Okay, match list is given. Okay, and partial derivatives are given in this case and we have to match. So let us, okay, this I am repeating again. Okay. Next is question number 63. Now here we have to do a match of list 1 with list 2. List 1 is partial derivatives, list 2 is the thermodynamic quantities. Now this has to be done using the following set of reaction. dg is equal to vdp minus sdt. Second is dh is equal to cp dt and du is equal to cv dt. Now if I am talking del g by del t, it will be minus s. So A will be corresponding to 2. Del h by del t. So dh by dt, it is a Cp. So this is going like this. Del g by del p. If dg by dp, if I do, I will get V. And if you do du by dt, you will get Cv. Okay, so A is 2 and B is 1. Okay, and C is 4 and D is 3. So the correct option is option 4. Okay, next is question number 64. Which of the species will not undergo disproportionation reaction? Okay, so generally species in their atom in its highest or lowest oxidation state will not undergo disproportionation. So if I'm talking chlorine, which is the central atom in all four cases, chlorine maximum oxidation state is +7, while minimum oxidation state is -1. Okay, so we have to just check which case either of the two conditions are getting satisfied. That is happening for ClO4 minus, which is where chlorine is +7 oxidation state. So the correct answer should be option 3. Okay, next is question number 65. In question number 65, statement 1, a spectral line will be observed for a 2px 2py transition. Statement 1 is incorrect because 2px and 2py both are having same energy, so there is no need for any photon to move from 2px to 2py. So statement 1 is an incorrect statement. Statement 2, 2px and 2py are degenerate orbitals. This is a correct statement. So statement 1 is incorrect while statement 2 is correct. So the correct option would be option 4. Next is question number 66. Identify the homoleptic complexes which are of low spin. Now low spin means that you should have a strong field ligand, and homoleptic means only one type of ligand should be there. So obviously the first option goes out of the picture. Okay, in all other cases you have got only one type of ligand, so we should consider. Now out of that, the strong field ligand will be observed in case of NH3 and Cn. Okay, so in these cases strong field ligands will cause forced pairing. So C and D should be the correct complexes for this answer. So the correct option should be option 3, C and D. Next is question number 67. In statement 1, an element in the extreme left of the periodic table forms acetic oxide. Now this statement is an incorrect statement. Why? You see, if I have group 1, group 2, okay, and on the right side I have got group 17, group 16, okay, then these will form basic oxides which are on the left side of the periodic table, and these will form acidic oxides. With water they will give acids, these with water will give bases. So option 1, extreme left giving acidic, is incorrect. Acid is found on the reaction between water and oxide of a reactive element present in extreme right. Extreme right is 16, 17. Okay, like SO3 plus water will be giving H2SO4, which is a acid. So we can say that this statement is correct. So statement 1 is incorrect, while statement 2 is correct. So this will give us option 2. Next is question number 68. The most stable carbocation from the following is, okay, they have given options. Now they have given certain groups which can exert resonance effects as well as inductive effect. Now CH3 through its plus H effect will create a negative charge here, here and here, and this negative will stabilize the positive charge. So CH3 will stabilize this carbocation. Methox OMe group, due to its plus M effect will create a negative charge here, here and here. So this is not directly stabilizing the CH2 plus. Okay, so this will not stabilize the carbocation that much. OMe through plus M effect will create negative charge here, here and here. And this negative will stabilize the positive charge through resonance. So this will stabilize the carbocation. And this is having only benzyl carbocation. So between 1 and 3, the hyperconjugation is less effective compared to resonance effect. So option 3 should give us the most stable carbocation. Okay. Next is question number 69. The correct order of complexes in terms of the crystal field stabilization energies. Now when you are talking about the delta naught values, okay, then remember that higher oxidation state of a metal will have more delta naught values. So CO3 plus will have complexes will have higher delta naught values than CO2 plus complex. And second thing is that chelating ligands will have more than non-chelating ligands because they will stabilize the complex more. And also octahedral complexes will have more CFSE than tetrahedral complexes. Okay, so if we use these three principles, we can say that CONHC-4 plus, which is a tetrahedral complex, will have the least because all the others are octahedral complexes. And between CONH3O6 plus and CONH3O6 plus, okay, CO3 plus with the same ligand will have higher delta naught value. And between CONH3O6 plus and COEN whole thrice 3 plus, this one will have more CFSE value. So the correct answer should be option 2. Next is question number 70. Now question number 70 is a reaction sequence question. So we'll write it. Okay, so we are starting with toluene and we are treating it with CrO2, Cl2 in CS2. Okay, and H3O plus. When we do this, we'll be getting benzaldehyde. And with NaHSO3, we get a sodium bisulfite addition of aldehydes. So you'll be getting something like CHOH SO3 minus Na plus. Now this is our residue A. Now this bisulfite addition product will undergo decomposition on adding dilute HCl to give back the aldehyde. So and this is the compound B. So A should be the bisulfite addition product and B should be benzaldehyde. So the correct answer is option 4. Next is question number 71. In question number 71, we have got niobium and ruthenium have x and y electrons in their 4d orbitals. What is the value of x and y? Now niobium is having z value equal to 41. So its configuration is krypton 4d4 and 5s1. So it's an exceptional configuration. So number of d electrons will be 4 here. In case of ruthenium also, it's an exceptional configuration. Z is 44. So it will be krypton, then 4d7 and 5s1. So it is having 7 d electrons. So total will be 11. So value of x plus y will be equal to 11. Next is question number 72. It is saying that 20 ml of 2 molar NaOH is added to 400 ml of 0.5 molar NaOH. So what will be the final concentration? So what will be the moles of NaOH? or rather millimoles of NaOH. It will be 20 into 2 plus 400 into 0.5. That is equal to 40 plus 200 or 240 millimoles. Okay. Volume of the solution. Final volume of the solution will be 20 plus 400. It is 420 ml. So molarity will be equal to millimoles by volume in milliliters. So it will be 240 by 420. So it will be like 12 and 21. It will be 4 and 7. So it will be like 0.57. Okay, so that will be equal to 57 into 10 power minus 2. So 72 answer should be 57. Next is question number 73. The compound with molecular formula C6H6 which gives only one mono-bromo derivative and takes 4 moles of hydrogen per mole has how many pi electrons? So C6H6, the degree of unsaturation will be 6 plus 1 minus 6 by 2. That will be equal to 4. Okay. Now this 4, if you think on the possibilities, one compound can be CH3, C triple bond C, C triple bond C, CH3. This on bromination will give only one mono-bromo product because both methyl groups are symmetrical. So in this case, we can say that this compound and this will is having 4 pi bonds, so it will take 4 moles of hydrogen. So this satisfies our answer. So it is having total of 8 pi electrons. So the answer should be 8. Next is question number 74. The complex Ni2 plus and dimethyl glyoxime contains how many hydrogen atoms? So we have to draw the structure of the rosy red precipitate. Okay, so it will be something like this: is CH3, CH3, and you have got nitrogen, nitrogen. One side will make OH, another side will make O minus. Okay, now here you have got Ni2 plus, so this will form the two coordinate bonds. And similarly, I can write nitrogen here and here, and these two can also form coordinate bonds. These two nitrogens will be corrected. Okay, and here we will write O minus, and here we will be writing O and H, and then CH3 and CH3. So this is the hydrogen bonding between the, and there are 4 rings, out of which 2 are rings due to complex and 2 rings are due to hydrogen bond. They are asking the number of hydrogens. So you have got 3, 6, 9 and 12, 13 and 14. So total 14 should be the answer for question number 74. Next is question number 75. Consider the following case of standard enthalpy of reaction. And here heat of combustion is given and they are asking the heat of formation for C2H6. Now for this first we write the formation reaction. It is carbon solid, okay, which is graphite, plus 2 carbon plus 3 hydrogen gas giving C2H6 gas. Now the delta H for this reaction, okay, will be heat of formation of C2H6. Okay. Now for any reaction I can find the delta H by either heat of formation values or heat of combustion values. Okay, so in case of heat of formation, it will be sum of formation enthalpies of product minus sum of formation enthalpies of reactant. But when combustion data is there, then it will be reverse. So if for this I can write delta H reaction. Okay, in terms of heat of combustion, it will be sum of combustion enthalpies of reactant minus sum of combustion enthalpies of product. So it will be sigma delta H combustion reactants minus sigma delta H combustion products. So what are the reactants? One is carbon, so it will be like 2 into minus 393.5 plus 3 into minus 286. Okay, minus. On the product side, you have got C2H6 whose combustion enthalpy is minus 1550. Okay, so if we do this calculation, then the value will come close to 95 kilojoules per mole. So the answer should be 95. Okay, so this is the last question in the numerical value section. Okay, and with this we have finished the paper discussion for the 22nd January second shift papers of JEE Main 2025. I hope that you uh, understood everything which we have discussed during this paper discussion and have got benefited from it. Okay, and with this, I am concluding this paper discussion. Okay, thank you everyone.